Hello everyone. My name is Manav Sanghvi from 4th Sem Computer Science Engineering at Pandit Deendayal Energy University. Our team consists of myself Manav Sanghvi, Vaibhavi Mistry, Nidhi Bhatt and Jainam Shah. We have done this project as a part of Operating System Lab project. Our topic is page replacement algorithm and we have made a website using HTML, CSS and JavaScript under the guidance of Sonam Nahar Mam. So this is our home page. And what is page replacement? In an operating system that uses paging for memory management, a page replacement algorithm is needed to decide which page needs to be replaced when a new page comes in. So let us learn more. In a computer operating system that uses paging for virtual memory management, page replacement algorithm decide which memory page to page out, sometimes called swap out, or write to disk when a page of memory needs to be allocated. Page replacement happens when a requested page is not in memory, which is known as page fault, and a free page cannot be used to satisfy the allocation, either because there are none or because the number of free pages is lower than some threshold. So page replacement is important because firstly, it helps the OS to decide which memory page can be moved out, making space for the currently needed page. And the ultimate objective of the page replacement algorithms is to reduce the number of page faults. So some of the important terms for the page replacement are page fault. A page fault occurs when a program attempts to access a block of memory that is not stored in the physical memory or RAM. The fault notifies the operating system that it must locate the data in virtual memory that it transfers from the storage device such as an HDD or SSD to the system RAM. So the algorithms for the page replacement are FIFO, LRU, optimal and LIFO. So FIFO, during the page replacement, the oldest page is replaced by the new page. In case of LRU, least recently used, the least referred page is replaced by the new page. In optimal, the page which is not going to used in the future will be replaced by a new page. And in case of LIFO, during the replacement, the topmost page in the stack is replaced first. So let us explore FIFO. FIFO stands for first in first out. This is the simplest page replacement algorithm. In this algorithm, the operating system keeps track of all pages in the memory in a queue. Then the oldest page is in the front of the queue. When a page needs to be replaced, a page in the front of the queue is selected for removal. The advantages are it is simple and easy to understand and implement. The disadvantages are the process effectiveness is low. When we increase the number of frames while using FIFO, we are giving more memory to process this. So page faults should decrease, but here the page faults are increasing. This is known as Baladi's anomaly. Every frame needs to be taken account of. The algorithm we implemented for the first in first out are: first, a FIFO algorithm can be implemented by creating a FIFO queue to store all the pages in the memory. We replace the page from the top of the FIFO queue. When a page is brought into the memory, it will be inserted at the end of a FIFO queue. So let us check the implementation. So here we will enter the reference string and we will enter the number of frames. So as we can see, first 7 comes and so it is a miss as because it is not present in the frame. Then 0 comes, which is also not present, so it's a miss. Then 1 comes, which is also a miss. Then 2 comes, which is also a miss. Then again 0 comes, which is already present, so it's a hit. Then 3 comes, and 3 replaces the 7th because 7th came first. So 3 replaces it, and then again 0 comes. So 0, it is a hit. So then the total number of pages are 7, the frames are 4, there are 2 hits and there are 5 falls. The hit ratio is 0.29 and miss ratio is 0.71. So this is page replacement algorithm using first in first out. So now let us check about other algorithms. So first we will check about least recently used. This algorithm replaces the page which has not been referred for a long time. This algorithm is just opposite to the optimal page replacement algorithm which we'll see in the future. And in this, we look at the past instead of the starting future. It is open for full analysis. So these are the advantages of LRU. In this, we replace the page which is the least recently used. Thus, it is free from Baladi's anomaly. It is easy to choose page which has been faulted and halted and hasn't been used for a long time. The disadvantages are it requires an additional data structure to be implemented and hardware assistance requirement is high. So the algorithm for least recently used is first start traversing the pages. If sets hold less pages than capacity, insert page into the set one by one until the size of the set reaches the capacity or all the page requests are processed. Simultaneously maintain the recent occur index of each page in a map called indexes. Increment the page fault. Else if current page is present in set, do nothing. Else, find a page in the set that was least recently used. We find it using indexing array. We basically need to replace the page with minimum index. Replace the found page with current page. Increment page faults, update the index of current page. If not present, find a page that is never referred in the future. If such page exists, replace this page with a new page. If no such page exists, then find a page that is referenced farthest in the future, replace that with the page with a new page. So let us check about this implementation. So we enter here the reference string and the number of frames. So here it's the same for 7 years, so it's a miss because 7 is not present in the frame. Then 0 comes, which is also a miss. Then 1 comes, which is also a miss. Then 2 comes, which is also a miss. Then again 0 comes, which is already present, so it's a hit. Then 3 comes, and 3 replaces the 7th because 7 is the least used in the past. So 3 is replaced by 7 in the frames. Then again 0 comes, which is a hit because 0 was already present. So here the pages are 7, the frames are 4, the hits are 2, the faults are 5, the hit ratio is 0.29 and miss ratio is 0.7. So now we check another algorithm which is optimal page replacement. Optimal page replacement algorithm is the best page replacement algorithm as it gives the least number of page faults. In this algorithm, pages are replaced which could not be used in for the longest duration of time in the future. That is, the page in the memory which are going to be referred the farthest in the future are replaced. The advantages are it is easy to implement, simple data structure are used, and it is highly efficient. The disadvantages are it requires future knowledge of the program and it is time consuming. The algorithm. So if a referred page is already present, increment hit count. If not present, find a page that never referred in the future. If such page exists, replace this page with a new page. If no such page exists, find a page that is referenced farthest in the future, replace it with a new page. So here we check about the implementation and we enter the string here. We enter the string here and we enter the frames and see. So similarly here for 7 is not present, 0 is not present, 1 is not present and 2 is not present in the string. So they all are missed. Then again 0 comes which is a hit. So hit and then again 3 comes. Then 3 is replaced by 7 which is not used in the future. See, let's check. So the 3 is here and 7 is not anywhere present in the future. So 3 is replaced by 7 here. Then again 0 comes which is a hit. So likewise see these are the places where hit and here it's miss. So here the total number of pages are 15, the frames are 4, the hits are 8 and faults are 7. The hit ratio is 0.53 and miss ratio is 0.47. So now let's check another and last algorithm, that is LIFO, which stands for last in first out. LIFO is an algorithm which uses the following processing of data in which the last items entered are the first to be removed. Thus, the new element is inserted above the existing element. The operating system keeps track of all the pages in the memory in form of stack. The newest page is on the top of the stack. When a page needs to be replaced, the page on the top of the stack is selected for removal first. The advantages are the LIFO makes it easier to replace the newest bit that arrived at the last in the main array. Simplest data structure are used and it is highly efficient. So disadvantages are, as LIFO follows last in first out, so it makes time consuming to execute tasks which were scheduled first. The algorithm is LIFO algorithm can be implemented by creating a stack to store all the pages in the memory. Now maintain a stack of all the pages currently in the main memory and remove the page that is at the top of the stack at the linked list. So now we check the implementation of LIFO and we enter the reference string and we increase the number of frames to 4. And then we submit it to check. So here similarly, so 7 comes, so it's a miss, then 0 comes, it's a miss, then 1 comes, it's a miss because they all are not present initially in the frames, then also 2 comes, which is a miss, then 0 comes, which is a hit because 0 is already present here, and then 2 is replaced by then 3 comes and 3 is replaced by 2 as 2 was the last which came, which was recently came. So 3 is replaced by 2. Then again 0 comes, which is a hit because 0 was already present here. Then 4 is replaced by 3 as 3 was the uh, last that came into the frame. So here similarly they are all replaced and the hits are 0 and 3 in the strings. So here the pages are 12, frames are 4, hits are 4, page falls are 8, hit ratio is 0.33 and miss ratio is 0.67. So this is all about the page replacement algorithms. So this all are the page replacement algorithms which are most important, some of the most important algorithms. So on behalf of my team, I would thank you everyone.